Hello, everybody. This is Mr. Tam back with another episode of Secondary 5 Science Option Math. Today, we are going to advance our study of a tan function in exploring how to, one, graph the rule given, graph the rule, if I give you the rule, or from a graph, determine the rule. We are going to start by graphing this function if we are given the rule. So first and foremost, let me get my pen out here. And we have the following. I have a rule that is y is equal to negative 2 tan of pi over 4, x minus 2 plus 1. So first we have to understand a couple of things here. I always like to start with the h and k when it comes to the tan function. So hk in this case is 2 and 1. Remember, the negative means that the x value is actually positive. So I have 2, 1. And 2, 1 is what we call the point of inflection. This was mentioned in the last video, where the function essentially deviates shape a little bit. It's still going to either increase or decrease, but it essentially is the part where it kind of swerves a little bit, if you want to call it that. So this is the point of inflection. So we're first going to label that. So that's right here. So that's essentially the middle of my function. Now, the a doesn't serve much purpose, so we are going to ignore it for the time being. What we're not going to ignore is how to find the period, and thus our asymptotes. So first things first, let's find our period. Our period from the last episode is pi over b. And the reason we have pi instead of 2 pi over b is because the period for a tan function happens in 1 pi rather than 2 pi's, like our sine and cosine that we've seen before. And because period is always positive, we have to divide pi by the absolute value of b. So in this case, I have pi, and I'm going to divide it by the b, which happens to be pi over 4, the absolute value of that. It's just saying 1 divided by a quarter in essence, which gives me 4. So it doesn't tell me a lot. It doesn't really tell me where to start and where to end. So I propose this to you guys. We learned last time that for a basic tan function, that our asymptotes are found at either pi over 2, so the equation x is equal to pi over 2, or x is equal to negative pi over 2 if we're talking about the first cycle. But here we've modified the x by multiplying it by an h, by multiplying it by a b value, like this, and subtracting an h from it. But it still represents x. So if we make this transformed x equal to pi over 2, and then isolate for the x, we can then tell where our asymptote is. So let's do that with this problem where we have pi over 4, x minus 2 is equal to pi over 2. So what we're going to do is we're going to now essentially move the pi over. We're going to move the pi over 4 over by dividing both sides by pi over 4. And if I do a half divided by a quarter, let's do that, 0.5 divided by 0.25, that gives me 2. So this cancels each other out. Here you have x minus 2 is equal to 2, where I now move the x over, or the 2 over, sorry, and I now have x is equal to 4. And what that means is my asymptote is going to be at 4. So from here, this is where the period comes in. I now know that also that from this one asymptote, I could subtract or add the period. So if I take the x asymptote and I add the period, well, my next one would be found at 8, which I'll just quickly sketch here, but it's not necessary in our scenario. And if I take my asymptote 4 and subtract the period from it, which is 4 minus 4, I end up with 0, which happens to be our y-axis. So I'm going to use a different color just to show you that there is indeed, oops, sorry about that, guys, a in asymptote right there, which means that, you know what, perfect. This actually fits right in between the two asymptotes we just drew. The last thing we have to consider before we graph is the sign of a and b. In a tan function, if I multiply a and b together and it gives me a value greater than 0, then my tan function will increase. Whereas the opposite is true. If I multiply a and b together and it gives me a negative value, that'll imply that it's decreasing. In this case, I have -2 multiplied by pi over 4, which would just be negative pi over 2, which means that since it's a negative value, I know that it's decreasing and thus looks like this, like I'm skiing downhill until I've reached the point of inflection, and I'm still skiing downhill and I approach 4. So this is how we plot the graph if we are given the rule. However, there's also another scenario that is possible, in that one must be able to tell the rule based on a graph. And so here's what I'm going to do for you guys. I'm first going to erase my rule here. And I'm going to erase whatever I drew on my graph. So I'm going to leave my very nice blue color because I don't want to erase too much. Don't want to have to restart. So here is the graph that I want you guys to draw. I'm going to have, let's say my asymptote at, I'm going to make it a very clearly different color. Let's have my asymptote at -2. And I'm going to have my other asymptote at 4. My value here is 2 for the x and 1 here. And I now want actually, you know what, guys? I'm gonna start this over. I'm so sorry. Let's try that again. I'm just gonna have a different function. Nope, you know what? We're gonna go with this one. It's okay. So I'm gonna have 2 and 1. And hang on a sec, guys. I'm just looking at my notes and I'm not happy with the function I've chosen. So I'm going to choose another function to do, or we're going to plot you another graph here and we're going to find the rule together. So I'm going to have one asymptote at 2 and my other asymptote at 4. Let's make it easy for ourselves. And my point of inflection will be at 3, 1. Increasing thusly. And I'm going to give you guys another point of inflection at 1, 1. And I'm going to give you another point at 0.5 and 0. That's my hint on how we solve these. So here I have 0.5, 0 as one of the points given, as well as you can see here, my point of inflection, 3, 1. So how do I go about solving the tan function using this? Well, first I have to write in my rule of f of x is equal to a tan of b x minus h plus k. So the idea is that you'll be able to find everything or plug everything in except the a. So I'm going to write down my variables on the side here, h and k of which are the easiest. I'm going to put down as 3 and 1. Optionally, you may also put 1 and 1, but in this case, I opted to put 3 and 1. And I'm also going to put in the b, because b can be figured out by taking pi and dividing it by the period. And the period, as we could see, lasts from 2 to 4. So it's a very easy one. So 4 minus 2 ends up being 2. So my period actually just ends up being pi over 2. Now, the point that I give you is very important because that's the key that you'll need in order to be able to solve this particular scenario. So here's what we're going to do. We're going to plug in 0 and 0.5 and 0 into my function, where 0 is equal to a, which is unknown, tan of pi over 2, and then my x value ends up being 0.5. My h ends up being minus 3 plus 1 as my k. Now, when I go to isolate a couple of things have to happen. I'm going to have -1 on this side, and I'm going to now have tan of pi over 2 multiplied by 0.5 minus 3, which happens to be -2.5. And if I were to simplify this for you guys so it's easier for you to find on the unit circle, you actually have -2.5 over 2, which is actually just 5 pi over 4, or -5 pi over 4. So let me just continue this down here. -1 is equal to a tan of -5 pi over 4. So this is where you have to look at your unit circle. And since we're going -5 pi over 4, we're actually going backwards on the unit circle. Now, of course, you can also, of course, plug this into your calculator, and it'll give you exactly the same number. So what I have here is -pi over 4, because I'm going backwards. This is -2 pi over 4, -3 pi over 4, -4 pi over 4, and -5 pi over 4. Now, -5 pi over 4 means that my coordinates end up being -√2 over 2, -√2 over 2, and √2 over 2. And when I divide √2 over 2 by -√2 over 2, essentially it's the same number, I get a value of -1. So I divide both sides by -1, and that gives me my a value to be equal to 1. Beautiful. I've now found my a value for this tan function, and thus I can write my final tan rule, which happens to be 1 tan of pi over 2 bracket x minus 3 or x minus 1, it's up to you, plus 1. And with that completes how we find the rule given a graph for a tan function. I hope this has helped you guys out. This is Mr. Tan with another episode, and I will see you in the next one. Au revoir, arrivederci, bye-bye.